Hello, hello, hello. Welcome to our midterm assignment. We've been tasked with creating the classic card game War for this final JavaScript assignment. So let's go over the rules first. When we're done, we should have created a game that deals 26 cards to each player from a deck of 52 cards. Iterate through each turn where each player plays a card. The player who plays the highest card is awarded a point. Ties result in 0 points for both players. And at the end of each round, the cards are discarded. So there should only be 26 turns here. And then after all the cards have been played, we should see a display on who won and what the final score was. So let's jump right into the code here. We decided to take the approach of creating classes. So we started with the card class, and I just thought through this game pretty realistically. So I pictured two people sitting in a room playing this game, and then started creating the pieces from there. So I knew I would need a card class, a deck class, some sort of game class that's responsible for like starting the game, managing the rounds, comparing the cards, and that such. And then I played around with a player class, and you'll see that that idea, although it sounded good on paper when we started, it got a little diluted here, and we worked out a way to make that happen too. So the first class is our card class. What is a card comprised of? That's comprised of a suits and a number. So that's our constructor here. The other thing we need to do is get a card value. So when it gets to the face cards and the ace, we'll need to have a value for that when it's compared, but also return a display that's in the language that you would use. So you don't call a king a 13 or a jack an 11. You would say my jack beats your 9 or my king beats your queen. But to the system, we need to compare the values. So we should return something when we get the card name that, this card value is of this suit. So this jack of spades or this jack of hearts. And we tested it out here. The next class that we created was the deck. So we had an empty constructor for this one, and we needed an empty array for our cards, and we needed a function to create the deck. So if you think about the deck, we would need 4 suits. And then for those 4 suits, we would need the numbers 2 through 14 representing the number 2, and then 14 all the way up here for our value for the ace. And so what we're doing here with our create deck class is we're saying, here's our array of suits. And then for each of these items, elements within the array, create the numbers 2 through 14 and push them to the new card class. This one was a fun one. So moving on from there, the next thing we need to do is get ready to get the players their cards. But first, of course, we need to shuffle them. Once we created these suits, we could test it, and we should see the 2 of diamonds as our very first element. And then the ace of clubs should have been our last element. So I wrote some test cases all the way down here at the bottom where we tested those out, and it worked. So I knew that we could continue on. The shuffle was difficult. I had to really think through the shuffle, and I reached out to one of our instructors, and he told me about something called the Fisher-Yates shuffle method. Sent me a link to a very good YouTube video on that. I won't include the link, but if you search Fisher-Yates shuffle method, you'll see this here, and I'll explain it the best I can. So basically, you take your array. Let's say it's the numbers 1 through 7. And you iterate backwards from that. So you can see that we use this card's length -1. That means we're starting with our very last element, and we're moving backwards, indicated by the I minus minus. And what we're telling this to do is we're using some JavaScript functionality here to randomize that card. So you take the 7, and then you pick a random number between one element 0 and 6, and you swap it with the 7, and then you do the same thing with the 6, and you take the element 0 through 5, swap one of those with the 6, and by the time that you're done, you have a completely random set of numbers. We also were able to test that down here. So we tested the shuffling and we could compare it then using kind of our same element. So we would check then again the same first and last element, and it should be something different than two of diamonds and ace of clubs. And if we looked in the console, we could actually see how it actually shuffled them. All right, so moving on from there, we need to start building our player class. Um, so this was interesting. The very first iteration of this, I thought the correct thing to do was to start to define a player one and a player two within the player class. But I kept running into errors because a single player is not really made up of two different players. So I had to change it around and just create a player deck with it. So this was the 26 cards that would be sitting in front of a single player. And then we we used the shift method to draw that first element and remove it from the array. And that was what we called our play top card. So if you picture 26 cards sitting in front of you, you would want something to draw that first element and then discard it, like we said. And then the last one, this was a really fun class to build, was our game class. So this is where all the game engine is stored. We wanted to start our player scores at 0. We wanted to initialize our new deck. We wanted to use our Fisher Yates to shuffle that deck. And then we sliced out the elements of the 52 cards to determine the player one deck. And we took elements 26 through 52 and gave those to player two. So they've been shuffled and split, and now each player has their 26 cards. So then we started to play through the rounds. So this all happens in the console. We don't have any breaks between rounds for this version of the game. It's really simplified for us beginning students. But this function here, play round, iterates through the 26 cards starting at element 0. We stop it before we hit 26. Our 26th round would be on the 25th iteration of I there. And then we define the up card so that we could compare them. So here we started to console out kind of the language. So we'd say this round, I plus 1. So because it's a 0 element array, we want to start with round 1 rather than round 0. And here's our statements to determine the round winner. So if player 1's up card, the number is greater than player 2's up card, the number, then we add a point to that player's score and we console log out player 1 beats player 2. And player 1 wins the round. If that case isn't true, if player 1's up card is not greater than player 2's up card, we jump down to our else if statement. Player 2's up card is greater than player 1's up card. Player 2 gets their score incrementally increased. And then we spit out the console log statement. Player 2's cards would be Jack of Spades beats player 1's card, 7 of diamonds. Player 2 wins the round. And then here's our case for a tie, else. If player 1's card is equal to player 2's card, no points for either of you. And then we console logged out the current score for each player in the round. So each round should show 3-2, 3-3, 4-3, 5-3, and so on like that. At the very end, we wanted to see a scoreboard. So the game is over, the final score. We display the player's points here with the template literal. And we add some if-else statements for who won the game. And then here's our game initialization down here. Let new game equal new game, and then new game play round. So let's run it using our live server. We'll go to the HTML. We will open our live server. And let's go to the console log to see what we got. Okay, so here's the game. It looks like we started out with an ace of hearts beats the 6 of spades. So player 2 wins that round. The current score is player 1 0, player 2 1. In round 2, ace of clubs beats the 4 of hearts. Player 2 wins that round too. He's off to a great start. Round 3, we get our equals here. So 6 of hearts is equal to 6 of diamonds. That is correct. No points for either of you. We saw that statement there in our code. And no change to the score there. We iterate 2. Player 3 continues the sweep. We got player 1 on the board here finally in round 6. I'm rooting for a comeback here. And as you can see, the game iterates on. We get another equals there. We're moving down. Oh, 20. Oh, player two's running away with it. And at the very end, we can see that after the round of 26, player two, 15 to player one's 8. So we see those points declared there, and player two wins the game. That was our project for our midterm, using all of our combined JavaScript knowledge. And appreciate you watching this video.